Mr. Klo, can you hear me?
Yes, Mr. Desmond, I can hear you.
Okay, then it's fine. Uh, I just wanted to notify the guys that um actually when I gave them update, I forgot they were attending today. I thought it was grade 10. So that means today's lesson will continue as planned. But that means yesterday's lesson will be done tomorrow. So let's see. Ethan, Nomfudo, Oneile, and Orefile. Did you guys hear me on that one?
Yes, sir.
Okay. I'm just hoping that everyone was able to get that. So just ignore that comment where I was saying we're going to be using Teams today and we'll be doing yesterday's lesson today. I only realized after that there was a lesson arranged for today, which is going to be done on Zoom. So the last message that I sent, I did indicate say I will further update you guys tomorrow. So chances are high that from tomorrow onwards we'll be using Teams. But I'll first have to do the setups and then from there update the timetable accordingly. Then only after I will give you guys an update. Then we will be using Teams. Okay, Mr. Thor, I am out.
All right, sir, then. Thank you. How are you all guys doing? Are you okay?
Yes, sir.
All right,
Yes,
if
sir.
that is okay. Okay, you know it is okay. What about others, guys? Are you all okay? Are you having the good weekend? Why is your energy low? What's going on? Bro, some people are quiet, but I believe you're all okay. We'll still be doing the revision on Euclidean geometry. And I think it will be the last day. Let me just share my screen. Share the screen. Boom. Can you all guys see my screen outside?
Yes,
Yes,
sir.
sir.
All right. Thank you, guys. Then let me jump into that work quizzer and question 5. Then I'm going to ask you guys some questions. I just want us all to go through these problems, guys. So question 5, there is saying in the diagram below, M is the center of this circle, then DABC. Okay, that is the circle, DABC. Those are the points on the circle. Therefore, now if we continue with the statement, EDF is a tangent, or we can see here, let me just enable my highlighter here, that EDF is a tangent to the circle at D, and FBG is also the tangent at B. Okay, and then now, as usual, I will go for this technique, Dr. Cape Town, the RCPT. So I'm going to ask you guys some questions and then to do some analysis. And then after we're done with this analysis, we can jump into the problems. So is there any diameter that exists in this diagram, guys?
No.
Okay, no, therefore we can scratch that out. Is there any radius that exists in this diagram?
Yes, sir.
Which one?
I think it's
I
MP.
love I love the energy of this one who is responding now. Oh man, the energy is good. You were saying is which one?
I think it's MP and MD.
You think?
MP and MD.
You're still thinking? Or now you are sure?
I'm sure.
Oh, okay. Yes, I agree that this is a. Okay, MB is a radius and MD is a radius. Therefore, MD is equal to MB, reason being radii. Okay, now we can come to the conclusion that MDB is an isosceles triangle. Therefore, now this angle will be equal to that angle, reason being the base of an isosceles triangle, or the angles opposite equal sides. Okay, we are done with the analysis of that radius. Okay, let me remove this mess. Now, from those analyses, we know that this angle will be equal to that angle. Okay, now we go to C for a cyclic quad. Is there any cyclic quad that does exist in this diagram, guys?
Yes.
Which one?
ADMP B.
You are saying it's AD?
MB.
This one?
Yes, sir.
Okay. Do you still remember the definition of the cyclic quad, Ethan?
Oh, wait, must it touch both circumference of the circle?
Yeah, all the points of that quadrilateral must touch the circle.
Then it's A, B, C, D.
Yes, 100% correct. Now, A, B, C, D is a cyclic quad. Therefore, now we know that this angle plus that angle gives us 180 degrees. Reason being opposite angles of a cyclic quad are supplementary. And then we also have got this angle and that angle. When we sum them up, gives us 180 degrees. Reason being opposite angles of a cyclic quad are supplementary. Okay, we are done because now I can see that property of exterior angle is equal to interior opposite angles. But if maybe I don't see it by any chance, and you see it that side, you can just shout it out. Okay, then we are done with that C. We can proceed to P for parallel lines. Are there any parallel line, guys, on the diagram?
No.
Oh, no, yes, there are no parallel lines. I can just cross that thing out. We go for the T. Oh, obvious, there is a tangent. They told us here that there is a tangent, therefore we can try to extract something there that can give us something for the tan chord theorem. We can just try to see if we can get something for the tan chord theorem. So we have got, let's first come to this tangent FDE. This is FDE. We have got this triangle here. Therefore, this angle here will be equal to this angle here. Reason being tan chord theorem. Also, this angle here will be equal to that angle there. Reason being tan chord theorem. We also have this triangle here. This one is also a triangle here. Therefore, this angle here will be equal to that angle, reason being tan chord theorem. And this one will be equal to that one, reason being tan chord theorem. Again, we have got, oh no, we are done with this side. Now we can go to that other side. This one, now for this tangent, there exists this triangle. This angle is equal to that angle, and this angle is equal to that angle. For both statements, reason is tan chord theorem. We also have that triangle on the other side, whereby this angle will be equal to that angle there, and this angle will be equal to that angle, reason being tan chord theorem. Then the last one, theorem for the tangent, is that one whereby they're saying tangent is perpendicular to radius. We know this theorem that if this is a tangent, this is a radius, and that radius intersects with the tangent. Where they intersect perpendicularly. Therefore, our reasoning is rad is perpendicular to tan. Radius is perpendicular to tan. Therefore, now we are done with our analysis. Oh, even if I didn't know that. Is there anyone who've got some question with this analysis that we just did now before I can dive into the problems? Are you still there, guys?
No questions, sir.
Oh, all right. No question for Ethan. What about others? Are you guys all right?
No questions, sir.
All right. Thank you guys for the feedback. Now the question is saying calculate the following angles with the reasons. Now 5.1 is requiring us to calculate the size of angle C, which is this one. Is there anyone of you guys who can share some idea of how we can approach this problem? Number 5.1.
Yes, sir.
Oh yes, please share what you're thinking.
I think we can say angle A plus angle C is equal to 180. The reason is that the opposite angles of a cyclic quad are supplementary.
Okay.
Yes. Then we say 140 plus C is equal to 180. Then we say C is equal to 180 minus 140. C is equal to 40 degrees.
Okay. I 100% agree. Opposite angles of a cyclic quad. I 100% agree to this statement and its reasoning. I agree. And then now we can continue to the next one, 5.2, the one that is requiring us to calculate the size of angle M1. Anyone guys who can give this one a try? That is M1 right there.
$80.
80. And then what's the reasoning behind the statement, Ethan?
Angles at the center is twice at the angle at the circumference.
100% correct. I agree to that. That is okay. Then the next one is 5.3. We are now required to calculate the size of angle B3. B3, okay, done, found this one to be 80. Now we want this one here. Anyone, guys, who can give this one a try?
I think it's 50.
You think it's 50. Why do you think it's 50?
Because we're going to use the interior angles of a triangle while saying that MB and MD are radius, meaning that B3 and D3 are equal.
B3, yes, I agree.
Yes.
Oh man, that's a good approach. 100% okay. Is there anyone, guys, who didn't get that or who didn't understand that, who still needs some clarification on how to get that P3? Anyone, guys? Okay. I believe you're all okay with this one. That this is 50 degrees. Okay, interior angles of a triangle. And then you also go for that reasoning for the angles opposite equal sides. Therefore, now the last one is requiring us to calculate the size of angle D5. D5 is this one here, this one here. Any one of you guys who can give this one a try? Oh, not too bad. Anyone, guys, who can give the last one a try? Number 5.4, that is requiring us to calculate the size of that angle D5 there.
So it equals to 50, and then tan cot theorem
is equal to 50. Are you sure? Check it well. The triangle. Oh, this is the triangle that we are having. Oh, the angle is between this tangent and that chord. Therefore, it will be equal to that whole angle. Therefore, it will be that 50 plus that 28, which is 78. Can you now see it?
Yes, sir.
Are you sure?
Yes, sir.
All right, thank you. So we are done with this problem. Any one of you guys who still got some questions on how we did something here? Are you guys all okay?
Fine, sir.
Okay, thank you for the feedback. What about others? Are you guys okay?
Yes, sir.
All right.
Yes, sir.
All right, thank you guys for the feedback. Then now we've got something to prove. Now we are not calculating. Yeah, we are proving, but okay. Anywhere I see a rider will always approach it using DRCPT. DRCPT, and then I'm going to ask you some questions, guys, after I'm done reading the statement. Let me go read the statement. In the diagram, AOB is the diameter. Oh, that's a powerful information. Okay, there is a diameter of the circle, and BC is a tangent to the circle. At that point, we can see at point B. Then BE and AF, BE and AF, this is BE and AF are produced, cut each other at P. Okay. And FE, where is that FE? Oh, this is FE here. And PD, where is PD? This is P, oh, that is D. Are joined. Okay. Then now we are given that D1 is X there. We are given that this is X here. Okay, interesting. And then now let's go for that ERCPT sum analysis. They said, okay, there exists, what am I doing? The RCPTs. They told us that there exists some diameter. This is the diameter. Do you guys agree when I say this angle is 90 degrees?
Why so?
Sorry?
Why is it 90 degrees?
Because if this is a diameter, that theorem of angle in a semicircle, do you remember that angle?
Yes, sir.
Yes, angle in a semicircle. You can also prove it by using theorem 2, angle at the circumference is 2. Angle at the center is 2 times angle at the circumference. So if this angle is x, let me use maybe different color, maybe a red one. If we say this angle is x here, this angle will be 2x. Okay, this angle is the angle on the straight line. Therefore, this angle will be 180 degrees. And then that angle there at the circumference is half of the angle at the center. The half of 180 degrees will be 90 degrees. Therefore, that angle there, this angle here is 90 degrees, reason being angle in a semicircle. Then that's the reasoning. Do you now get it?
Yes, sir.
Are you sure?
Yes, sir.
All right. Thank you. Therefore, that is 90 degrees. Okay. So that we can also see that that will be 90 degrees angles on the straight line. Okay. And then what else can we cook? R, the radius.
Sir,
We have the red. Yes.
wouldn't if3 also be 90?
What?
If3.
E3. Or
If
E3.
was it
Where
E3?
is?
Not F3.
Oh, F3. F3 is this one. What could be the reason behind the statement?
Isn't that also semicircle, sir?
Oh, yes. Thanks, man. I didn't see that. I appreciate it. This is that diameter. It also subtend that angle. Yeah, man. Thanks. I appreciate it. It's 90 degrees. I agree. Thank you, man. Okay, that is 90. And then we are done with that diameter. Therefore, we saw that using that diameter, these angles are 90 degrees. Also, I didn't see that they form something like this. And then this angle is equal to that. We can also say angles in the same segment. This is equal to that. Angles in the same segment, or angles subtended by this chord, or angles subtended by this arc. Okay? And then now we go to R, the radius. This is the radius. This is the radius, but that is not going to help us. Okay, we can just skip it. We go to C, the cyclic quad. Oh, this is the cyclic quad. This one here. And then this angle and this one, they add up to 180 degrees. Reason being the opposite angles of a cyclic quad are supplementary, and also this one and this one are supplementary. Okay, we are done with cyclic quad. We also have noticed that bow tie shape. Then for P parallel lines, there are no parallel lines. T, the tangent is there. There exists this tangent. Then there's this triangle. Therefore, this angle will be equal to that angle. Okay. And then, okay. There's also this triangle here. This one here. This angle will be equal to that angle. Okay. And then let me ask you this last one. Do you guys agree to me when I say to you that this angle is 90 degrees here? CBA.
Yes, sir.
What's the reason behind that?
A radius or line drawn from the center is perpendicular to a tangent.
Oh, yes, 100% correct. I agree. Yes, that's the reasoning. Then we are done with the analysis. Then now we can quickly dive into those proof of these riders. The first one, 7.2.1, is requiring us to to prove that PFDE is this one. Oh, this is a good question. To prove that this blue quadrilateral here is a cyclic quad, it's a 5 marks question. Oh, it's a good one. Anyone, guys, who can share some idea of how we can attack this problem? Anyone, guys? It's not that hectic. Remember? Oh, okay. What do you think?
I think that we can use that opposite side of cyclic quad are supplementary because we already find that
So can I just please interrupt you a little bit? You said opposite what?
opposite sides of a cyclic quad are supplementary.
What do you mean? Opposite sides of a cyclic quad are supplementary?
We find E1 which was 90 degrees.
I just
Me-
want to correct you somehow. You are saying opposite sides of a cyclic quad are supplementary.
Yes.
Can't you maybe notice something wrong about this reasoning? Opposite sides of a cyclic quad.
Opposite angles.
Yes, that's correct. Opposite angles, but yeah, that's a good try though. Yes, opposite angles of a cyclic quad are supplementary. That's a very good approach. Yeah, and then you can continue now.
So we'll say E1 is equal to 90 degrees.
This one, right?
Yes.
And then you give the reason. What's the reason?
Angles in a semicircle.
Okay, 100% correct. I agree. And then
And you say E2 plus 3 is also is equal to 90 degrees.
this one here.
And we can say angles on a straight line.
Okay, 100% correct.
Then we say F3 is equal to 90 degrees.
F3 is 90 degrees. Okay, and then what's the reason behind that?
This can be angles in a semicircle or angles subtended by the same diameter.
Oh, okay. All right. I agree.
Then
100% correct. Then
we say F1 plus 2 is equal to 90 degrees.
this one here, right?
Yes, then we say angles on a straight line.
Yes.
Then we can conclude that F1 plus 2 plus angle F plus angle E is equal to 180.
This is equal to 180 degrees because that is 90
Yeah.
plus 90 degrees. Therefore, we satisfied that property of a quadrilateral that if the opposite angles of this quadrilateral are supplementary, then that quadrilateral is a cyclic quadrilateral. Then you are done.
Yes.
I agree to you. That's a good approach. 100% agree. Does it make sense to everyone, guys? Thank you, ma'am, for your explanation. Does it make sense to everyone?
Yes, sir.
Yes, sir.
Are you guys sure?
Yes, sir.
All right. Thank you, guys. Then Boom, boom. Let me erase. Now we go to the second one, 7.2.2. Write down with reasons 3 angles that are equal to x. Oh, this is a good question. This is just three angles that are equal to x with reasons. Just 3. 6 marks. Oh, this is good. Now we are convinced and we know that this is a cyclic quad. What can you do now? Oh, if there is a cyclic quad, what can you do to find this was our x? To find some angles there. Boom. Let me see. Let me try to see something. This is equal to that. Oh, I only see 1. Why do I even see just 1? And then oh, okay, if it's there, it will also be here. If it's here, it goes there. Okay, I think I'm done, guys. This side, I'm just waiting for you now to find it. It's not, oh, it's somehow hectic, but once you find the first one, I think you can just use that one to find the other 2. Because we have proved this, now we are sure that this is the cyclic quad to this circle here. That is a cyclic quad. You guys can cook something there. Let me draw it. Oh, this is a nice cycle now. I1. What am I doing? Yeah, this is now. Let this point be there. This be here. This be here. This be here. Yeah. Right now. Let this be. What's now happening? Yeah. That is a cycle. It is a cyclic quad to that cycle. And then now find 3 reasons that are equal to x. I mean 3 angles that are equal to x with reasons. Are you guys still trying to figure it out? Seems like I'm left alone here. Are you guys still there with me in the room?
Yes, sir.
Oh, all right. Are you still trying to figure this out?
I have the first one, sir.
You have the first one.
Yes, sir.
Oh, you can share it with us, man. I'd love that. Which one is it?
F2.
F2, I 100% agree. What's the reason behind that?
Angles in the same segment.
Angles in the same segment, I 100% agree. Then if you found that, now I'm allowed to do this circle. We are no longer going to need that circle. Okay, this is X. Now you can come back to the bigger circle and work out something that we did using this analysis.
A2.
Sorry?
A2.
You are saying A2, and then I agree that this is equal to that. The reason being
Angles in the same segment.
angles in the same segment. I agree, sir. And then now the last one. You are almost there. Now you can just go back to this analysis that we made here and then try to. Those theorem that involves the tangent will give you this one now.
Oh, tan cot theorem.
Tan
P1,
cot theorem.
P1, P2, and P3 equals to 90, and which makes wait.
Just go look for the tan cot theorem, something there, and then okay, that angle is opposite that chord, then it will be equal to the angle between the chord and the tangent. Just try to look for it. Are you now stuck? Are you winning that side? How is it going that side, Ethan? Are you winning?
So is it P1 and P2 equals A2?
You are saying this one is equal to A2.
Yes, the tan cot theorem.
Oh, look. A2 is this part only. This part, right?
Yes, sir.
Therefore, if it's only that part, it will only be the angle in this triangle. For sure, now you can see which angle is equal to that A2. Can you now see it? Okay, let me just do this. This is the line. Oh, where is the? Okay, like this. You said is equal to that. Can you see your mistake somewhere there? Because A2 is in that triangle. Therefore, if you want to use tan chord theorem, it should be equal to the angle that is between the chord and the tangent. Therefore, it will only be equal to this one here. Can you
P1.
see that? Yes.
Ooh.
Can you see that?
Yes, sir.
Oh, yeah. All right. Are you comfortable with that now?
Yes, sir.
All right. Is everyone okay with this 7.2.2, guys? Are these guys still even here? Let me just check. Oh, you
Yes, sir.
guys are quiet. How many people do we have? Oh, we've got 4 people. Oh, that's a lot. That's a lot. Then we are done with that. Now let's go to the last one, 7.2.3. The one that is requiring us to show that PD, or is PD, PD, PD. This is PD, that this PD is parallel to BC. Oh, this is the simplest question. And then we just want to show that these lines are parallel. Anyone who can share some technique on how we can approach this problem, guys. We just want to show that these red lines here are parallel. Are you guys still there with me? Eh? You left me. Are you still there? Oh, these guys left me. Hey.
What? No, sir.
Yeah? Were you saying something, Ethan? Oh, these people. I heard some voices. Anyone, guys, who can give this one a try? Oh, I think maybe it might be a little bit tricky to you guys. Then let me just take it. We want to prove that these lines are parallel. So the only part that involves parallel lines, we know that is maths. Maths is fun. So if we can see some angles like that, we found these angles that are equal. Therefore, these angles are, these lines are parallel, reason being the converse of corresponding angles. Then you state those equal angles. Then if we have got something like U, and this angle plus that angle gives us 180 degrees, we can say this line and this line is parallel. Reason being the converse of co-interior angles. And then with this one as well, if this angle and that angle are equal, such that these lines forms that shape, we can say this line and this line are parallel, reason being the converse of alternate angles, then you state those equal angles. Therefore, now for this one, we can see that these lines form that Z shape. Let me just draw a clear picture. I've got this, I've got this, I've got that. They form something like that. Then in 7.2.2, we found that this angle is X. We are given that that angle is X. Therefore, you can come to the conclusion that this line and this line are parallel. Reason being the converse of alternate angles. Then you state that now B1 is equal to D1, both equal to X. Then you are done just like that. Does it make sense, guys?
Yes, sir.
Okay.
Yes.
I had feedback from 2 people. What about others? Does it make sense to you guys?
Yes, sir.
Are you sure?
Yes.
Who is this one that doesn't want to give feedback? I had feedbacks from 3 people. Does it make sense to everyone, guys?
Yes, sir.
Yes, sir.
Oh, Ethan gives feedback. Or
Yes,
Ifile,
sir.
or Neile. No, Fundo. Are you okay with everything that we just did?
Yes, sir.
Are you sure?
Yes.
Oh, all right. Oh, I should do this every day and come check. Yeah, if everyone gives me feedbacks and if everyone is comfortable with everything that I've explained. Otherwise, guys, let's end here for tonight. I appreciate your presence. Thank you, guys. Have a good night and enjoy the rest of your Sunday. We'll meet on the next lesson.
You too, sir.
Thank you, Ethan, man.